Okay, so let's talk about chapter 2. Chapter 2 is all about variables. Okay, so we're going to talk about what is a variable and what are the basic parts of a C++ program. So we've seen a very, very basic C++ program last week, where you did Hello World. And so we're going to talk about it a little more in depth now. So hopefully you already know some of this from last week. So some basic things. We have something called a comment. When you're doing your code, you should write documentation for it. Just like when you're submitting a paper for class, you write your name on it, you write your date. We write documentation for our code, except we can't just write our name at the top because then the code would look and say, what is this? So the way that you can get it to ignore that code for documentation is to make it a comment. So you put // and then anything you write on that line is ignored by your compiler. So it doesn't matter what characters you use. You know, you can write a description and it doesn't care if you use what kind of punctuation you use, because those are comments, that's documentation. So at the top of all your programs, you should have your name and the date and just a brief description of what the program does. Okay, so those are comments. At the top, you also have something called a preprocessor. And so we're always going to add this IO stream one. The IO stream is useful because it's going to allow us to do output and input. Okay. So we're always printing something out. So that's the C out. And so we did like the hello world with the C out. So if you don't do the IO stream, you wouldn't be able to use that. And so that's a way to bring in that code, that file into there so that you can use that code in your C++ code. We don't have to have the namespace on there with the std, but I like to have that on there because if you don't put that on there, every output line you have to put std. Okay, that's the standard output. And so when you're doing input and output, you'd have to put the std, and it's just, I think it takes extra work for that. So I like to put the using namespace std at the top, and then you don't have to write std on every single line that you have output. Okay, so you can write that at the top, and then you can just say C out instead of putting that std in the front of it. All of your programs in here are going to have something called main. Okay, we call this a function. And basically, whenever you run your program, it knows to go to main. So if you change that name to something else, it won't know to go there. It's like when you click run, it says, oh, go to main and do whatever's in there. Okay, and so that function has to be called main and written like that. Now, we'll explain a little bit later on what that int means. Today, we're going to talk about what int means, but that's really what you're returning from the function. And we haven't really talked about functions yet, so it's just not really going to make a whole lot of sense, but it's saying that it returns an integer, but we haven't really talked about that. So we're just going to write that there for now, and we'll understand it as, you know, the course gets further along. So your main is going to start with a curly brace, and it's going to end with a curly brace. Every time you have an opening curly brace, you're always going to have a matching closing curly brace. Now, some people when they're coding like to put it up here with the parentheses here for main, and some people like to line it up here. It really doesn't matter to me. I do like to put the closing one lined up with the I and int though, so you can tell that that's the end of main. So that's the beginning and that's the end. So that's called a block of code. And so for now, all of our code's going to go in that block of code. Everything we want to do is going in there. And so last week we did a hello world, right? This one says hello there. And whatever you want to output goes inside quotes. And that's called a string. Okay, that's the text you want to print. And so you put the text you want to print, and then you put a semicolon saying you're finished. That's called a statement. Whenever you put a semicolon at the end, that's the action that you want to do. I want to print hello there to the screen. Now the return 0 is dealing with this int right here that I was talking to you about before. Functions are going to, well, some functions return, and this one returns an integer. And so return 0 actually just means that everything in main was successful. It's okay. So you're just returning 0. If you make it there, it was successful. And so that's just the default that people put at the end, return 0. It'll make more sense when we talk about functions, but for now, we're just going to put that on there at the end. If you don't put it, it will default for you, but we're going to just add that to the end. Okay. Kind of a lot to think about to hit first, but the more we do it, the better it gets, hopefully. So there's lots of different special characters and they all mean something. You'll notice in programming, if you've never programmed before, it's very detail oriented. meaning that if there's supposed to be a period or a semicolon and you don't have it, and you have 500 lines of code, that one little thing causes the whole thing not to work. Okay, so it can be very frustrating. But the editors that we have now, they try and help us. They tell us what line is not working. So you can go look at that line and hopefully you can say, oh, I'm missing a semicolon, or I'm missing a period, or this is misspelled. So, you know, you can pick out the different lines and what might be wrong with them. But we have to be very detail oriented. We have to look character by character to see why is it not understanding us? Because if there's something called a syntax error, that means that C++ doesn't understand. Basically, you're trying to communicate and it's not understanding. Okay. And it could be a misspelling, it could be missing punctuation, it could be a lot of things. So we have to look character by character and see what's wrong. Okay. So we already talked about C out and we practiced a bit with this. And so this one would just print programming is fun to the screen. Okay. But you can also put the arrows again, and it will just continue that. So when we start working with variables, you can put a string in a variable by putting the arrows like that and putting the string, then the variable, then a string, and we'll talk about what a variable means. But that top one, we'll just say hello there, just like it would before. You can also put them as two separate C out lines. It would still print in one line though. Okay. So you're probably saying, why would I do that? So you can add something called end L. End L means end line. Okay. If you use the little arrows and you put end L on there, that will actually end the line and you'll get the next one on a new line. And so this one will print, as you see on the screen, on a new line. Okay, but if you don't put the end L, then it won't print on a new line. Okay. Make sure that's an L, not a 1. I get a lot of people put a 1 there and it doesn't work. It looks like a 1 though. Okay, so it stands for end line. The other thing you can do is you can use a special character, escape character called the \n, okay? And make sure you use the right slash, because there's 2 slashes and the other one won't work. So if it ever prints the slash in your output, if you actually see the slash, you did the wrong one. So just go change it, because whenever you put /n, \n, it should actually count as like an enter, okay? Every time you put that inside of quotes in your code, it counts as an enter. It's like hitting the enter key, because you can't actually hit the enter key in your code to get an enter in the output. So you either have to use end L or \n, okay? If you put 2 \n, you'll get 2 enters. So keep putting them. One thing you have to be careful of, some people don't like how it runs right up against the S here. If you start putting spaces before and after this, you'll get spaces down here as well. Okay, every time you put a space inside quotes, you actually get a space in your output. So just be careful that it doesn't mess up your output, how it looks, because if you hit spacebar inside of quotes, that registers as a character and it actually prints that space in your actual output. Okay, everybody okay so far? Okay. So we talked about this already. At the top, you're going to have some includes. When you're doing C out, you're going to have that IO stream that we're going to want to put at the top. We're going to use the namespace as well. Namespace helps us with not having to put the STD. So those are things that go at the top. It doesn't matter if that goes before or after your comments. That's up to you. But it is going to go before your main. Okay. Because what happens is it actually adds that code to your file. Okay. So that you can use it. And you're not going to put a semicolon at the end of the line. So I know I said statements, but that's not technically a statement. So it's not going to get a semicolon at the end. You've hopefully heard the word variable before, okay, in math class. It may have been a while, but you know that somebody gives you A and they say A equals 2 and they have equations. Well, you fill in the 2 everywhere there's an A, right? So you've probably done that before. You solve for things in algebra, right? You kind of remember variables. Variables in programming are a way to keep values for later, okay? So it's a memory location that you're saving and you're giving it a name so that you can refer to it, and you put values in there. And then whenever you say that name, that identifier, it can pull the value that's in that location, okay? So we don't have to remember memory addresses in here, okay? We don't have to know what memory address is C++ storing this in? We just have to know, hey, C++, we're going to have this variable. We're going to call it A. And whenever we say A, you're going to go get me that value and pull it out for me, okay? So whenever I create a variable, I give it a name. We'll call that the identifier, right? And then I tell C++ that identifier, that variable name, and it pulls the value for me, okay? So one thing we have to know when we're working with these variables is there's different types. They're called data types, okay? So when we're going to store a value in memory, we have to tell C++ what type of value we're going to store. We have to know how big is that number going to be when we're storing something. So this is an example of a variable definition where we're telling C++, we're going to have this variable and we're going to name it number. If you see the circle, and the data type is going to be int. Okay, that's a common data type. Int stands for integer. Have you heard that before, integer? Integer just means whole number. That means no decimals. Okay, so anytime we use an int in programming, it doesn't have decimals. Okay, there's different data types for decimal numbers, but int means whole number, and it's a very common type that we're going to use in here. Okay, we don't write it out, we just write int. Okay, all lowercase, and then whatever name you want to give that variable that makes sense, you can give. In this example, it's number. Okay, now when you're creating your variables, you can give them values. Okay, we call these literals. Okay, so if you're giving your variable value a string, we call that a string literal. If you're giving your integer a value, we call that an integer literal. Okay, so like 12 would be an integer literal. Hello there would be a string literal. So we have identifiers, and then we have literals, the values that we're actually giving them. Okay, just some keywords to remember, right? Okay, so you can see that we have a variable up here called apples. Probably stands for the number of apples, right? And it's an integer. This is going to be a whole number because you don't have decimal number of apples, right? So you have a whole number of apples. And then down here it says apples equals 20. So 20 is called the integer literal, right? But apples is the actual name of the variable or the identifier, okay? And the data type is called int. Okay, so just some words to remember, but I'll try and keep throwing them out there for you so you get used to those words. Okay, and then we're just going to print off here how many apples. So you can see when you're printing, you can print the string. I like to have a label instead of just printing the apples, like the number of apples, because when someone looks at your output, all they would see would be a number, right? You might say, what's that number? What is that? And so you know how you label things, and when you're doing something, maybe in math, when you get an answer, maybe you write 20 apples or however, you know, you put a label with it. What is that number? So when you're programming, you should put a label with it instead of just printing the values. So it says today we sold, and then it actually will print how many apples, bushels of apples. Okay. Now, when you're getting used to this, you have to make sure you put spaces inside of your actual output, inside of your codes, because if you don't put a space here, you won't get a space in your output here, and it'll run that B right up against the number 20. And so you always want to test your output and see if it looks good, because when somebody's looking at your output, if your words are running together, that's no good, right? So when you're doing it, it's hard to get used to this, but when you're doing quotes, make sure you put spaces so it looks good when you run it in your output, okay? Now you notice that there's no quotes on this apples here, right? That's because apples is a variable, it's my identifier. If I put quotes around it here, it'll actually say today we sold apples, bushels of apples, because it'll just print what's inside quotes. If you remove the quotes, that tells C++, this is an identifier. I need to go look for this. This is a variable name. And then it says, oh, it's here. I'll just print whatever's in there. I'll pull that from memory, and that's what you'll get, whatever number's in there. But if you put quotes around it, it means just print it the way it is. Don't look for it as an identifier. Does this make sense already? Okay. So the ones that are highlighted there are called string literals. Those are your strings. I know that's kind of an interesting word to get used to. That's your text that you're printing. That's your string literal. And then the identifier would have been apple, right? Apples. Okay. All right. So we're going to talk about naming our identifiers, our variables, okay? So identifier, variable, same thing. We have this list of keywords in C++, and the reason why I show you this is because when you're naming your variables, you can't pick any of these names, okay? These words are taken, these names are taken, because if you try and name it these things, that means something to your compiler and it gets confused. It's like, wait, what do you want me to do? You want me to create this? Oh, wait, I can't because I'm confused, okay? So normally you won't want to use these names anyways. But if your program's not working, you might want to check and just make sure that the variable name you're using is not a keyword. That might be a problem, okay? So this is an example of a variable name that would be okay. Items ordered, okay? Now, when you're naming your variables, you will never put spaces in your name, okay? So if your name happens to be more than one word, you will push your words together, okay? To make one word. Now, if you want to, you can put an underscore between the two words. Not a hyphen, but an underscore. Underscores are acceptable. Not a hyphen and not a space, okay? Now you notice that the O in ordered is capitalized. That's so that you can see the difference between the two words, okay? So it's not required, but a lot of people do that because it makes it look nice. We call that camelback casing because you can see the difference between the two words easier than if you were to not capitalize anything. So normally people start variable names with a lowercase letter. And if they have another word after the first word, the first letter will get capitalized. And if they have another word, same thing. So you can have as many words as you want, but we'll keep it short and sweet and to the point, okay? So we don't want to have variable names that are a sentence long, okay? Because every time you use that in code, you have to rewrite that. And programmers don't like to type. They like to keep from typing. They like to make things short and sweet, okay? So we don't want it so short that we don't know what we're talking about, but we don't want it so long that we have to keep rewriting this 5-word variable name every time we want to write a variable. So like, for example, items ordered is perfect. It tells you exactly what you're talking about. You don't have to call it, these are the items that I ordered, okay? But don't call it X because then people in your code are going to say, what is X? And it's confusing, okay? Yes, you can put a comment that says X is this, but this just makes it nice and easy for people to know exactly what you're talking about. Nobody's confused. So make your variable names something that are meaningful that tell people what you're talking about. Just don't call them A, B, C. Okay, give them, again, if you're talking about items, at least call it I for items. Okay, that makes sense, everybody? Okay, so there's some rules you have to know. You cannot start with a number. It has to be an actual alphabetical character. It can't be a digit, but you can have a number in your variable name. It just can't start with one. Okay, so like you can have a total 1 and a total 2, but you can't have 1 total 2 total. Okay, you can't have a space, but you can have an underscore. You can start with an underscore if you want to. I don't usually do that, but you can. It is possible to start with an underscore. You can have a mix of uppercase and lowercase. Normally you start with a lowercase and then words after that, the first letter gets capitalized. And then no other special characters. You're not putting like exclamation points or, that kind of thing, okay? No spaces for sure. Everybody with me? And try and make it make sense, something that deals with what you're talking about. So if you look at this one, like the first one is valid. It might take a while to get used to that because it looks strange. The second one's valid as well. Now, in this case, it doesn't matter if you capitalize the S because there's an underscore there. So you can completely read it and it's up to you. But if you capitalize it, everywhere you use it, you have to capitalize it. You have to follow the same capitalization that you choose for the first time when you created it. This one can't have period. You can't start with a digit, so this one's incorrect. And then you can't have a $sign. That makes sense already? Any questions so far? Are y'all okay on Zoom? Am I going too fast?
We're good.
Good. Okay, just let me know if you have any questions. Okay, so the integer data types. There's a lot of them, but really we're only going to use int in here because we're not going to have numbers as big as a long. Okay. I don't have anything to teach you that would have a number that big, okay, that large. So you should know that they exist, but we're not really going to use them in here. So the main one that we're going to use is int, okay? Now you might say, why don't we use like a short int or anything like that? Those are harder to work with when you're dealing with equations, because when we do equations in here, the processor automatically is going to work with integers, not with shorts. And so it's hard to deal with that type of data. So I know it saves space, but it's not worth it usually. But you should know that you do have those data types. If it's imperative, you save space. There are ways to do that, but most of the time people will just use int, because int has a wide enough range of numbers that it's convenient for most uses. Okay. And again, we're not going to get to longs in here because I don't have numbers out there. Okay. So you should know the different categories and the different ranges and everything. Okay, so when you're going to use a variable, you have to say what data type it is. So if you're using a whole number, it would be one of those data types I showed you. And so here's some examples. Like, for example, you might have a variable called length. That's an integer. Width is an integer. You might have an unsigned int. You can, if you have multiple variables, you can put them on the same line if they're the same data type. So like length and width are both integers. So I could just say int length comma width, and it will do both of them. It really doesn't matter if you want to put them on separate lines or the same line, it's the same. You should just know, part of it is you'll find your own style of programming, what you like to do. You might like them on separate lines, but part of it is also being able to read other people's code, because most of the time you're working with other people. And so they might do it differently than you. So it's also good to know other ways of doing it. So if you see their code, you say, oh, I know what they're doing. That's not how I would have done it, but I know what they're doing. Okay. Okay, so you can see up at the top here, I have 3 variables. I have a checking variable that's an integer, an unsigned integer that's a miles, and then a diameter. Okay. And then all 3 of those have values. We call that initialization. Whenever you give your values, whenever you give your variables a value, okay. And so these are the identifiers, these are the variables, and then these are the literals. Those are the values that you're putting into them. So we call that initialization, okay. And then this is just printing out that information. And so it will get some with practice, you'll get used to what all of this means. But remember, the \n means new line. So when you're looking at it, like we have made a long journey, and then it's going to print the miles, and then it's going to print the word miles after that, and then a new line. Okay. So you might say, okay, well, why didn't this just go up here? And it could have, but it's going to be up to you. Most people, when they're coding, they try to keep it on the screen. Okay. So because this was going off the screen, it's on the next line. Okay. But it depends on your screen size and what you're working with. But what you don't want to do, you might have a really big screen, but other people might not. You don't want to have to scroll forever to see your code. Like, you don't want this to be one giant line that you have to scroll forever to the right to see, because technically you could just keep putting arrows out here to the right and continue it forever to the right. But that's one thing that bothers me. If you're ever on a web page, you have to scroll this way and that way and this way and that way. It's nice if it's just on the screen. So try and make it fit on the, a normal size screen when you're working with it. Don't have it continue to the right forever. Yes, it works, but other people looking at your code, you want to be considerate that eventually you'll be working with other people and I'll be looking at it. And so we don't want to make it hard for people to read. Okay. So this example has the variable items ordered, and it has a integer literal 15. Okay, so we call that, again, initialization, because it's given a value. So if I were to say, what is items ordered? It'd be 15, right? Okay, so some examples again of integer literals. So this is the variable declaration or definition. Same thing. And then this is initialization, where you actually give those variables values. We call those literals. Is everybody with me on the name? So I know I keep repeating it, but I just want you to be your book and your quiz and everything is going to say, okay, now which one of these is a literal, that kind of thing. And I want you to kind of know, oh yeah, okay. Now which one of these is an integer data type? And so you have to know those words. What does that mean? Okay. So when you're doing it, all your integer literals, integer is default. So you don't have to put any special characters after it when you're using an integer because that's the default. But if you want to use a long, then you're going to use L after it to force it to be a long. Again, we're not using long in here, but if you were ever in a case where you needed to, then you have to put that special L after it for long. Okay, there's something called a char data type, that stands for character. Okay, so if you needed to do just one character, now let's say this confuses students because let's say they wanted to put the number 10 in there. That wouldn't work as a char, right? Because that's actually 2 characters. So we don't typically use digits for character data anyways, because numbers are represented differently than like characters and strings in the computer. So that would be a number data type, not like a char usually. But what char is good for, usually you might ask somebody, would you like to continue the program, enter Y or N? Y for yes, N for no, that kind of thing. It's a quick and easy way to do comparisons, which we'll talk about later. So char is great for that, like a really easy comparison, because strings are a little bit more complicated. Strings have more than one character, but a char only has one character. So when you're working with one character of data, it gets single quotes around it, and a string gets double quotes. Okay, char can only have one character though, it can have more than one character. Okay, so we just say char for char, and then whatever variable name, whatever identifier name you want to give it. So in this case, I called it letter, right? Letter is the name of that variable. And then letter is initialized with a value of C. Okay, now it's a capital C. Remember that your computer is going to represent capital and lowercase c differently. Okay, and we have to remember that because they are completely different binary representations when you talk about them. And I know you don't have to memorize binary for this class, but they're like completely 2 different characters, even though they look the same. Okay. So I already mentioned that single quotes around a character, right? Double quotes around a string. So in this example, you have a variable called letter, and the first time letter is A, and it's just going to print off. So it should just print A. When it prints it, it doesn't print it with the quotes though. That's just for putting it in there. And then you can actually switch what letter is. So you can always actually erase what's in there and put something over top of it. So you have this memory location, this memory address, and it had the value of A, right? But then it has the value of B later. Okay, so then you print that off. So just make sure that when you're doing it, if you're going to erase what's in there, you already used what you had in there before. So like the order matters, because if I didn't print the letter when A was in there, I wouldn't get it if I replaced it with B, right? And you always have to make sure that the sum reasonable, right? You declare your variables and you initialize them before you use them. Okay, so you can't try to use it and print it out up here before you declared it and told C++ that you have that variable and what data type it is. So it goes in order. So at the top of main, you want to tell C++ all the variables you have. So you declare them, okay, or define. Some people call it define. And then initialize them, give them values, give them literals, and then work with them, print them out, do whatever you want to do with them, but you can't do it the other way around. Okay. Now, if you're using a string is a series of characters, more than one character, right? So at the end of a string, we have something called a null terminator, and that tells us it's the end of the string, okay? So if you have hello, there's an extra null terminator in there that ends the string, okay? So they're a little more complicated, but as far as we know, pretty much going to work the same as all the other variables, okay? But when we're working with strings, we're going to include another preprocessor at the top. So include string, you're going to put that at the top. And then when you have a string variable, you just put string, and then whatever name you want, whatever the identifier name is, the variable name. And then when you're putting the data into the variable, when you're initializing it with a string literal, you're going to put double quotes around your string. Okay. So char, you put single quotes, string, you put double, right? Okay. And then you just print it off just like you do with all the other variables. So if you do a cout, if you wanted to print the first name, then you would just put the name of the identifier, the variable, and then this puts a space. So I know that looks strange and you're probably saying, what does that do? This will actually put George, and then this will put a space and then Washington. Because remember, if you don't put this in here and you just put first name, arrow, arrow, last name, it'll put George Washington right up against each other and you won't get a space. So the way to get a space in your output is to actually use the space bar inside of quotes. And so you have to actually add an extra space in here with quotes around it, or you won't get a space between the two names. And this is something that you'll realize when you're doing it. If you did first name, arrow, arrow, last name, and then you printed it, you would be like, oh, that doesn't look good. How do I fix that? And that's what programming is all about. Sometimes you just have to try it and see, and then think, that didn't do what I wanted it to do. How do I fix that? You know, because you might not code it all correctly the first time and have it work 100%. You may think, oh, it works this way, but when you run it, you realize that didn't give me the answer that I wanted. And then that triggers, how do I fix that? How do I, you know, make it look the way that it's supposed to look? Yes.
When you're working with strings, do we also use the include IO string whenever we start with the code at the top too?
Yes, you'll have both. Yeah, because that does the cout. If you don't do that, then it won't do the cout. Yeah, so you'll have a little collection of preprocessors. And you don't have to memorize anything at the beginning because your quizzes and everything, you can use your notes. So if I ask you any questions about like IO stream or anything, you have programs and examples in your book that you can quickly look for things like that. It's just by the end, after you've been doing it for the final exam, you'll have to know all the different things. But by that time, you will have much practice with it. So I don't expect you to. Students always worry when they get into, you know, code, and they want to do their assignment. Let's say you want to do the diamond assignment. They worry that they can't do it based on memorization. They don't want to look at anything to do it. I don't think that's the best way to learn how to code. I believe that you should be allowed to look at other examples when you're doing it. So I don't expect you to just get into online GDB, for example, and know everything to write all your assignments without looking at anything else.
Yeah, I think that's what my last professor made us memorize, and I could not do it.
No, I think you have your resources. Why not use them, right? I mean, by the end, hopefully you know enough that you can do the final exam. But I mean, I don't expect you, like when you're doing your assignment, go look at an example in your book and say, oh yeah, that's what the preprocessor looks like. I don't have to have that memorized because you're going to type it 1,000 times. By the end, you'll know it. But at the beginning, you haven't done it before. So how are you supposed to memorize it? But it will become memorization even if you don't want it to, because you're typing it so much that it's like, oh, okay, I've done that a bunch of times. But that's the thing. So when you do your assignment, if you come to me for help, I'm always going to ask you, well, what other examples can we look at? Have we done this before? Can we bring up the exercise that we did? And can you look at that? Can you have both of them open at the same time? Can we copy and paste a little bit? Can we copy and paste and make adjustments? Does that make sense, everybody? Because I think that's how you're going to learn, through experimenting, right? Not through memorizing. That's how I do it too. I could take something and say, oh, this code does this. Well, how can I make it do this? Okay, this is what I need it to do. And then again, like you try something and you're like, oh, whoops, that doesn't work. How can I fix that? And that's how. I don't expect you to say, oh, I'm no good at this. I can't do this. I didn't get this right the first time and I don't have it memorized. And so students always feel that way. And I don't want you to feel that way. I don't expect you to have it memorized. And just because you don't have it memorized, that doesn't mean that you don't know it. That just means you need a little more practice with it, right? So don't worry. This is a very, very large book. And it's a lot to know, right? But the more you do it, the more you practice with it, the better you'll feel, the more comfortable you'll feel. And that's why we have to do a lot with it. Unfortunately, we have to do a lot of examples and we have to talk about it and we have to read about it and we have to answer quiz questions. We have to do review questions, because if you just read about it, we won't learn it, right? Okay, so the more code you see, the more you practice, the better it gets, hopefully, the more examples. So this is an example of a string. So you can see you have a movie title. See how the variable starts with a lowercase letter and the second word starts with a capital. This is the identifier or the variable name. This is the data type. This is the string literal. Okay, that's the value. We call that initializing it, giving it a value. Now, you would have a problem if you went to do my favorite movie is movie title here, but you didn't initialize it. So if you ever see you didn't initialize it, that means you're trying to print a variable value that you never told it what it was. Okay, so if you create a string, but you never put a value in there, that means it's not initialized. So if you ever go to use it, you're gonna have problems because it doesn't have a value, right? So this Wheels of Fury would print here where it says movie title. See how that doesn't have quotes on it, which means that it's an identifier. It's gonna look for that actual whatever's in there and print that instead of actually printing movie title. So far so good. And again, it takes a little bit of practice to remember to put a space here. So that'll probably happen to you at first, and then you'll hopefully look at your output once you test it. You always want to run it and test it and say, oops, I need to fix that, and then go back and run it again. Okay, so it's a simple fix. Whenever you see there's no spacing in your output, don't leave it like that. Try to figure out how can I fix that. Okay. So we talked about integer data types. We're going to talk about decimals. Okay. There's 2 decimals we're going to use in here. There is a long double, but we're not going to have numbers that large. Okay. But you should know it exists. But we're going to have floats and we're going to have doubles in here. Okay. The difference between them is the amount of precision that you get. So if you're working with a monetary amounts, you want to go with double because people care about their money. Okay. So the double is more accurate. If you're talking about converting Celsius to Fahrenheit, float is probably good enough. I don't need to have the precision that goes with the double. So it depends on how much accuracy you're going to get. That's what the difference is. But a double takes up more room than a float because it's larger. Okay, so it depends on when you're evaluating it, which one to use, how important accuracy is over how large the program is going to take up. Okay, most of the time we just go with double because decimal numbers automatically default to double. Okay, even if they're small numbers, okay, that only have 1 digit of precision, they automatically default to double. And so float takes extra work for us to do it. Okay, so I'm going to show you how to do it. But let's take a look at the size. So a float is half the size of a double. So it's good if you need to save room and you don't need the accuracy that comes with a float. Okay, the double has 16 digits of precision. So that's a lot. You don't always need that. Okay. And so all numbers are default double that are decimals. So we'll talk about how do we fix that? How do we change that? So if you look at this one, you have an example of a float and you have a double. Okay. And so, you know, if you need it, I mean, you can use a double. I think in this class we'll most of the time stick with double. If you want to go with float, you can. Because when you're doing equations, we haven't really done equations yet. If you put a number in your equation and you want it to be a float instead of a double, you have to put a little f after it. Okay. And so if you forget to do that, then it changes all your numbers to doubles. And when you try and save it in a float, then it has issues. So the float makes a little more work. I mean, because you have to, every decimal number, you want to put an f after it to keep it to be a float instead of a double, whereas a double is automatically default. So you don't have to do anything special with it. Most of the time, storage is pretty cheap, and that little bit of space that you're saving between a float and a double isn't really going to make a difference. But if the speed and the storage space that is very important, then you want to go with float. Okay, but most of the time, a lot of people just default to double. Int and double are the 2 main data types for numbers. Int is whole number, double is decimal. Another one is called bool. Okay, a bool is a Boolean. Have you heard Boolean before? George Boole is a mathematician, if you've heard him before. Basically, Boolean means that we're going to be true or false. Okay, so if you've ever done any type of like discrete math or logic class, you probably have done like different tables where you have to do truth values, right? Zeros and ones. And so that's called Boolean logic. And so we don't do a whole lot with bools right now because we don't have decision making in this class yet. But when we get to something called conditionals, that's decision making. We'll have more Booleans then. But you should, they are a data type, so that's why we mention them here, but we don't really use them right now. But a bool evaluates the true or false, the 0 or 1. Okay, so it's, again, it's used for decision making to know if something happened or didn't happen. If you want to, you know, when we get to decisions, we'll have a flow chart where we have the diamonds and we'll have to say like, this way is true, this way is false, and we'll start talking more about Booleans. But for now, just know that a bool is a data type that is true or false. So, and true is represented by 1 and 0 is represented by, or false is represented by 0. So in this example, if you had a Boolean data type that's called bool value, and you set it true and you printed it, would actually put a 1. Okay. And then if you set it at false, it would actually print 0. Remember, 1 is true and 0 is false. Again, not going to be used too much for the next couple chapters, but and in the future we'll use it. Okay. If you need to know the size of a data type, you can ask. There's a function for that called size of that'll tell you. Okay. And we talked about this. It's called initialization. Variable assignments is where you're assigning the data type to the variable and initializing it with a value. You can't do the value first equals and then the variable name. You have to put the variable name first equals then the value. So that won't work. Okay, you can do it on one line if you have more than one thing. So if you're talking about like this length equals 12, it's an integer, width is also an integer and it's 5. And then this area doesn't have a value yet. It's probably going to be calculated with the length and the width. But all 3 of them are integers. And then 2 were initialized and the third one, the area is not initialized in this particular case. It will probably get initialized later as a result of an equation. Okay. This one has 2 variables written in one line that are both integers. One is month, it has 2, and days has 28. So it'll just say month 2 has 28 days. So February has 28 days, right? Everybody okay so far? Easy? Okay. You can use something in C++11. I don't typically use it just because it's kind of a new feature that I never really got used to using, but it is kind of handy. You can put auto as the data type, and based on the actual value you're initializing with, we'll decide what data type it should get. So it's kind of cool. I just kind of forget about it, I think. Something called scope that's going to be important. We talked about this a little bit. You can't print out a variable that you haven't actually initialized or haven't declared yet. And so that's called scope because it goes in order. So you don't have access to that variable because you haven't declared it yet. So you just have to make sure that you have it in order. And then when we start talking about other functions, we'll talk about, you know, what functions have access to which variables, but we only have one function called main right now. So that's the scope right now. It's just that one function. But it is important that you worry about the order that you put them in the function, because if they're not in the right order, then you won't have access to them, and that's called scope. It's like you haven't gotten there yet, so you don't have access to it yet. So this isn't a problem. You can't print out value because you haven't declared it yet. That's called scope. Okay. So everybody good so far? Here's where we get to the fun part. We start doing some arithmetic. Okay, this is all basic arithmetic. Everything should be able to be done in your head or with simple, you know, if you need a calculator, that's fine, but it should be pretty easy arithmetic. So we've all done, hopefully, addition, subtraction, multiplication, division. There's a new one called modulus, okay? Modulus means remainder. So it's like we want to divide these 2 numbers and we want the remainder of what's left over. And so that's useful in certain situations. I always tell students, for example, you're working somewhere and you need to give change to people. Okay, let's say that you're trying to figure out how much change to give someone. So if someone gives you 79 cents, right? You know, you have to figure out how much change to give them, right? Or let's say it costs 79 cents and you have to figure out how much more change you're supposed to give them. So what you have to do is you have to figure out, okay, let's divide it. So we need to divide by the quarters to figure out how much quarters I should give them. divide by dimes to figure out how much dimes. But the other thing you need to do that you might not think about is you also have to figure out, once you divide by quarters, how much is left over, so you can figure out the dimes, and then divide by dimes and how much is left over, so I can figure out the nickels, and how much is left over to figure out the pennies. So this leftover part is where the modulus comes into play. So you can actually divide out, okay, if I were to take that, let's say I have to give somebody 79 cents change. Let's take that example because it's pretty easy with the quarters. So if we divide 79 by 25, we need 3/4, right? Okay, so something that we're going to do in C++ that's going to be new is called integer division. So whenever you're actually taking, and this is a new one that you may not have heard of before. And so if you were taking 79 divided by 25, because a quarter is worth 25 cents, the answer to this question would actually be 3. Because they're both integers, they're both whole numbers, so you get a whole number answer, you don't get a decimal answer. So whenever you're dividing, remember that integer division where you're going to get the integer. And it's actually perfect for figuring out change, because you don't want to tell someone 3 point something quarters, right? It should just be 3. But the problem is, okay, now I know it's 3/4 for the 70 to give me the 75 cents, right? But what do I do with the rest of the change I'm supposed to give them? If I'm supposed to give them 79 cents, right? Then what I want to do is I want to actually take 79 modulus 25. Now the answer to that question is actually divide 25 into 79 and figure out the remainder. So if 25 goes into 79 3 times and it gives you 75, there's 4 left over, right? So 4 cents would be left over. And that's how you figure out, okay, now how many dimes, nickels, and pennies do I give? And of course, there's not 4 cents isn't enough for a dime or a nickel, so then you get a pennies. But that's how you figure out the equation. You go with the remainder. So the modulus is going to be the most confusing because your calculator doesn't do modulus. Okay, you have to do the long division and then figure out what the remainder is left. It is helpful for situations like this. Again, you don't always use it, but there's certain situations where it is helpful to know how much is remaining. And that's what we're going to talk about. That's going to be the most tricky part, is integer division that I just talked about, not getting the decimal number, and then modulus, probably. Did you have a question? Okay. All right, so the rest of it's pretty basic. I know that you know how to subtract and add. And again, the hardest part is going to be the division, okay? Because this looks strange. If you're taking 7 divided by 3, right, you would think it would be a decimal number, right? But we're not going to get the decimal because 7 is a whole number, 3 is a whole number, so the answer just comes out to be 2. So it doesn't round, it just chops the ending off. It's called truncating, just erasing the ending, the decimal. And it's good because in the case of the quarters, you wouldn't run it to round up and give an extra quarter, right? So there are techniques for rounding, but this isn't one of them. Integer division doesn't round, so you have to know that. It can cause some major issues with your equations, or it can help you. It depends on what you're doing, but you have to know that it exists because it will probably at some point make your equation not work the way that you think it will work. So we have to remember that. And then when we're taking 7 divided by 3 with the modulus, 7 modulus 3, you would actually see how many times does 3 go into 7? It goes in 2 evenly, and that becomes 6, and then 7 minus 6 gives you 1. You with me? That might take some practice. Okay, so if you look at this program, just to give you some examples, kind of small up here, but there's some basic variables I have here, like base pay rate, regular hours, and then this is just how you do the equations. You have these variables, right? And then you put the equations down. Now it's getting used to this type of writing is a little tough at first, but you're going to put the equation on the right hand side of the equals. Like you always say, the variable equals and then the equation. And then whatever the equation amounts to, like whenever you solve it, whatever value that comes out with gets assigned to the variable on the left hand side. Okay, so just think of it like when we were doing this before, base pay rate equals 18.25. This 18.25, this literal, goes into this variable, it gets assigned to this variable. This is the same thing, except it's going to calculate this and then put it into the variable on the left. I know normally it's the other way around. You say equals at the end. And so it's kind of a different way to write it. The variable goes first, equals, and then the equation. And whatever the equation comes out to be, the value for that, that goes into the variable. We call that assignment. So that equal sign is actually called an assignment operator, because what happens is whatever's on the right-hand side gets assigned to the left-hand side. It gets put in that value. Okay, and then when you print it, it'll give you the answer. So what's nice about using equations with variables, C++ is going to do the work for you. It's going to do the calculations. So every time that variable changes up there, these change, then these answers will change down here. Now you're probably saying, but these are just numbers that don't change though, so they'll always be the same answer. That's right. So eventually the goal is to do input so that these numbers change, so that these numbers change. For right now, we don't know how to do input, so we can't change these values except actually just going into that hard-coded program and changing the values. But the goal is to do input to change those values to change the output. That's where we're headed. Okay. But for right now, you're probably saying, but if somebody wanted to do those calculations, would they really get into the C++ code and change that 18.25? No, they probably don't know how to do that. So you need to do input so they can input that and not know how to get into the code to change that. But we don't know that yet. So that's where we're headed. Everybody okay with this stuff? Okay. Are y'all okay online?
We're good.
Yes.
Good. Just let me know if you have questions. Okay. So we talked about this integer division. So if you have 13 and 5 and you're dividing, you actually get 2, even though it's a decimal answer normally. 91 and 7 gives you 13. Okay. But what if you wanted the decimal? Well, 91 and 7 divides evenly, so there is no. But 13 and 5 should have a decimal. So how do you get the decimal? Well, if you just make one of the numbers a decimal number, then you get a decimal answer. Okay. So it doesn't matter which number you make a decimal, you can make both of them a decimal. But if one of them is a decimal, you get a decimal. So the 13 is still an integer, but the 5 is a decimal. So it gives you a decimal answer. If you would make the 13.0, it would do the same thing, or if both of them. It doesn't really matter with the 91 divided by 7 because it's 13 anyways, but it will give you 13.0. It will give you the decimal. Okay. So if you're talking about variables, if these numbers were actual variable names, if they were identifiers instead of actual numbers, you would have to change the data type of one of the variables to be a double instead of an int. Because if you end up with 2 ints, you're dividing, you're not going to get the answer you want. So you have to be careful because sometimes when students are trying to figure out like an average, for example, they'll have a counter that keeps track of how many objects there are, and that counter will be an integer because typically counters are integers because you don't have decimal numbers, right? So they're trying to figure out how many times or how many items they have, so they'll have a counter that's an integer, right? And then they might have a total that's an integer. And then when they actually divide them, then they get an integer answer, okay? So they have to make sure one of those is a decimal number, one of those is a double, because if both of your numbers are integers, you'll get an integer. And it might not be what you want it to be. So this always, I just want to show you one more example because this always blows everyone's mind. If you were to, make this bigger. If you were to have something like this, normally 1/4 is 0.25, right? Not when you're doing integer division. Okay. So you would have to do something like this to get 0.25. Or, everybody with me? Okay, so keep that in mind because that'll probably throw you for a loop sometimes and you'll probably wonder, why is my answer 0? Probably integer division in there somewhere because integer division can cause problems like that and make the whole answer 0. Okay. So another thing you want to practice with is modulus. 13 modulus 5. So you actually say how many times does 5 go into 13? So it actually just goes in 2 times, and then 13 minus 2 gives you 3. Everybody okay with that? Okay. When you're doing modulus, you're not going to have decimal numbers. Modulus is going to be working with 2 integers, okay, for the remainder. Okay, and we kind of already talked about this. I don't make you have comments throughout your program. Now, that's not to say that they wouldn't be useful. You can do it if you want to, but the programs at the beginning especially are very simple. So there's not a whole lot to comment. If you wanted to put a comment for the Hello World program, you could put a comment after that says print Hello World to the screen. But I think it's pretty obvious that that's what it does. So you don't have to comment every line of code. If you want to, some students want to because they want to remember what the different lines do. It's a good way to make a note to yourself. Say, when you're looking back at your code, what did this line do? What did this equation do? So if you want to comment your code, it doesn't bother me. Just don't make you do it for a grade. So if you want to comment your code up with, different explanations of what everything does, or you want to let me know something about your code, that's a great way to do it. But I do want you to put your name and your date and a basic description of what the program does at the top. Okay. Now, when you're doing it, you can do comments after any line that you want, because, like, for example, if you want to put a comment here to say that this is the length in inches, this / tells C++ to ignore the rest of this line. So you wouldn't put it at the beginning of the line because it would ignore the whole code that you have, but you put it at the end of the line. And you don't want to put a extra space between these 2 slashes or it won't work. But you just put / and whatever you want to say about that line. Okay, so you can put extra comments. Like, for example, if you wanted to put that this calculates the rectangle area, that's a great comment, but you don't have to put it. But, you can put these extra comments throughout your code. Now, at the top, because you're putting more than one line, you're putting your name and your date and what the program does, you can do a multi-line comment, okay? A multi-line comment starts with a slash and an asterisk, and then anything you want to say, and then an asterisk slash, and then it stops it, okay? Make sure you put the asterisk slash or your whole program becomes a comment, okay? So this, you can put whatever you wanted in there, and that's where you can write your name and your date and everything at the top. You could do this as well, but if you're just going to do one line, you could just do //. I like to use this as what we call a debugging tool too. So you heard that word debugging before? Trying to troubleshoot, figure it out, right? So let's say your code's not working. I like to use comments sometimes to figure it out. Okay, so let's say I have a whole section of code that's not working. Well, yeah, I could erase it and put it in like Notepad for later and bring it back in later, but I don't want to do that most of the time. So I might say, I'm going to comment out this code that's not working and put it back in later, okay? And then I'm going to add code line by line to see how it works, okay? So I might put a multi-line comment in there for a whole section that doesn't work, but like a /*/ for this whole section, this isn't working, worry about this later. And then later, when I figure it out, I'll put it back in there. I don't have to erase it. Erase it, it's gone for good, right? Or like maybe one line isn't working, so you just comment out that one line and worry about it later. Okay. Sometimes you have variables that aren't going to change. They're called constants, okay? If you know it's not going to change, like a tax rate or how many are in a dozen, things like that, pi, those are constants. So we put CONST, and that stands for constant. That means that that particular data is not changing. That value that I have for there, like the number of states, is going to stay the same, okay? And then most of the time, when we do constants, we put them in all capital letters so that people know that they're constants. So if you were creating like pi or the number of states, you just put it in all capital letters to tell people, and you put the underscore because you can't tell the difference between the words if you have multiple words. Okay, but then I can't change this value later in my program. Like once I initialize it, it stays that value, and constant means you can't change it. Okay, but it stops people from changing it. Okay, but what's nice about it, you might say, why even have a variable if it's not going to change? It's nice if it were ever to, you have it at the top, you could change it at the top and it will change everywhere else. Like if it were to, you have one access point for that particular thing that you're talking about throughout your code instead of having an actual number throughout your equations. And so, and it's also easier to understand, I think, when you're looking at code, oh, this is pi, or this represents this. And so, say, where did that number come from? Or, it kind of tells people what it is there for. Okay, so here's an example with pi. Okay, and you can see that they're capitalized because they're constants. All right, lots of instructors are different. As far as programming style, I believe that you pick which way works for you. Now, there's some things that I do that do bother me, okay? So some things are supposed to be indented, and that bothers me when it's not indented because it makes it hard to read. So like C++, it doesn't matter if things are like lined up all on the left-hand side, or if things are one giant line of code, it still works. Now, some languages won't let you do that, like Python, you can't do that. It won't work. But C++ you can, but that doesn't mean you should, okay? Just because you can. So when you're doing it, automatically, all the editors that I've used, when you hit enter after a main function, it automatically indents it for you. So don't take that off of there. Like leave it indented, because what's indented inside main tells people that that's inside of main, and it makes it easier to read. If you put it over to the left and push it over here, or have everything zigzag across, it makes it hard to read. Just like when you're doing papers, when you mess with margins and sizing and spacing, and people still can read the words on the page, but it doesn't make it easy to read. It doesn't flow nicely, right? It's the same thing with code. The indentation helps people read it. And so that part. Now, as far as like, should you put a space after your comments? That doesn't matter to me. I don't care if you put extra space. Some people don't like spaces, so they jam everything up. Some people like to put a space after every line. That doesn't bother me, okay? You find your groove, what works for you, but indentation does. Just pay attention to indentation. But as far as other things, how many lines do you take up for comments? I don't care if you put your name and your date in the same line. Whatever, if you want to write it as a paragraph, whatever makes it look nice and becomes, easiest for you, if that makes sense. Okay? Anybody have any questions about that? Okay, now I want to take a look at Canvas and make sure everybody's on the same page. So again, what you're doing is we talked about chapter 2 today. I hope that this week or next week you will be able to read the whole chapter. I don't have that being due until next week. So I do want you to, before you read chapter 2, to focus on finishing chapter 1. So if you haven't gotten a chance to take the quiz on the syllabus in chapter 1, I want you to do that, please. If you haven't gotten exercise 1 done, or you haven't gotten credit for it because I can't read your file, maybe please see me about that so we can get that fixed. I think all of you introduced yourself already, but if you haven't done that, please do that. That's an easy 5 points. So make sure you covered everything that was due here. And then make sure you cover everything that's due this week, okay? Please make sure you've gotten credit for anything you've turned in already. If you turned in stuff for this week, I haven't gotten to grade your assignment 1 yet, so don't worry about that. But please make sure you do that before you start reading chapter 2. Now, after you get this work done, remember Monday is a work day. So I'll be here if you want to come in and you want to work, and if you get stuck, you can ask questions. If you want to work from home, you can do that. If you get stuck, I'll still be answering emails, and I can even set up a Zoom meeting with you. But some students like to have that extra help, so it helps. But we only meet on Wednesdays in person or on Zoom as far as a class session for participation. The Monday is optional, okay? So Monday, what I want you to do is always look at the syllabus and see what you should be working on. So for Monday, I want you to try to do the chapter 2 exercises. So I'll show you those in just a second. And then I want to talk about this discussion board activity, okay, that I want you to start working on. And if you haven't finished reading chapter 2, that's another thing I want you to work on Monday or this weekend, is to get further along in chapter 2, because when we come back to class next week for chapter 2, I want to ask you some questions about the chapter and see how well you understood it. So we're going to play a game called Cahoots together. It's not for a grade, but it's just to see. So if you do well on that, then you'll know that you're understanding it. But if you haven't read it, you won't know if you understood it yet. And then I want to do like a little group project with you and make it more interactive on Tuesday or on next Wednesday. Okay. So make sure you read it by next Wednesday. Okay, so let me show you. So again, make sure you covered everything here, okay, before you move on to here, okay? But I want to show you the exercises. I want you to try to do these on Monday on your own, or if you come to class in case you get stuck, I'll be here. It should walk you through step by step. If you don't want to use C++ shell, that's fine. You can use online GDB or Visual Studio. But I want you to try to do this exercise, okay? And then submit that. That should give you an idea of, you know, how to code what we're talking about in that chapter. And then the assignment, oops, I'm the wrong one. The assignment, more to load. The assignment doesn't tell you step by step how to do it. And so it's going to be worth more because you have to kind of figure out, okay, how can I take what I did in the chapter and what I did on the exercise and kind of apply it to this? I don't know why it's taking so long to load, but let me see. I'll open it over here. Okay, so it gives you a rubric of what you have to do. And so you have to have your comments, a name for the assignment. You have to have a variable to store the number of kilometers, and then an equation. And I gave you the equation, and then you're going to print out the answer. How many kilometers equals how many miles? So pretty basic, hopefully, program. And you don't have to really worry about that until next week. But I just wanted to show you that. Okay, and review questions are going to be just practicing some basic things. So these, you can just type the answers right into the box in Canvas. For me, if you want to create a text file, you can do that as well. If you want to create that and save that in case you want to work later, do half now, half later type thing. But you know, you can actually test this out in online GDB if you're not sure. Just try and create and see if you're creating it correctly. You can test your answers and code them and see if they actually work. Okay. And then, okay, and then the quiz, and then this discussion activity. Hopefully you'll get to have fun with this. You're actually going to kind of work together on this. So the part one is you're going to post 5 things that you would store information into. Like I gave you some examples here, like 55 crayons. And then part 2 is somebody has to come and actually write the data type and initialize it. So for 55 crayons, how they would do that is like this. An example, and I wouldn't use a double because you don't have a piece of a crayon. You don't count that as a, right? So integer works well for a number of crayons because you don't have a decimal number of crayons. At least I wouldn't think you would be worried about that. So think about what you're talking about. Is it something that would be a double or an integer or a string or a char? So this is part 1. You posted the discussion board some examples, 5 things, and then somebody has to reply and answer how to do that. Now, what you might want to do is once someone posts their 5 things, you might want to claim it because I don't want multiple people doing the same one unless they have to. Okay, so if there's none other left, let me know. I can post some extra examples, but I don't want 5 people answering the same because there's not a whole lot of ways you can answer it, and so I don't want people just copy and paste and doing the same thing. So what might happen is if somebody posts it and then someone's typing it up and then someone hits send before someone else does, then you feel like you did extra work and you didn't get to do it. You have to start all over. So what you might want to do is say, I'll do this one, right? And that kind of claims it. And then later on, you can work on it. And then if somebody says, I'll do this one, don't do a different one. Okay, if that makes sense. It's kind of an easy way to claim, hey, I'm doing this one so that 2 people don't work on it. And then one person hits submit before the other one. They have to redo everything on something somebody else does. Because I've had that happen before. And they say, I already did this one now, but somebody beat me. So does that make sense? Everybody understand? So part 1 is due on the 6th and part 2 isn't due till the 13th. So once we get part 1 done, then we can worry about part 2 the following week. So. Okay, but so what I'll do when I'm grading it is I'll just grade. Well, if you do both parts, I'll grade both. But when it's due, when I've gone through it, I'll grade and I'll say part 1, 5 points, for example. But you only get a 5 out of 10 because you haven't done part 2 yet. So it'll look like your grade's not good because you only got a 5 out of 10. But the second week, when you come back and do part 2, you'll get the other 5 points. Everybody with me? So it's just because you haven't done part 2 yet. So don't stress if your grade looks like it's decreased because you only did half of the assignment. When you do the other half, you'll get your grade back. Okay. And then I also wanted to mention when you're looking at the grade book, because I know people had questions about it. Remember that I said that I don't take off for late exercises or readings. So if you got a 0, if you only get a check or an X for exercises, because it's either complete or not complete. So if you have an X, make it a check by the end of the semester, please. Go back and make everything a check by redoing it as many times as you need to get it right. Okay. And the reading, if you got a 0 because you didn't do it on time, when you go back and read, it isn't actually, it's letting you do it all the way till May. It'll mark it in the grade book. It's just, that's a recommended reading date if you want to stay on track. I do that because I could say you have to read it by this date or you don't get credit. But then if I don't give credit, then people probably won't read it. And if you don't read it, then you won't know what's going on. So I feel like it's better to give credit for reading it, even if it's late, than just say you don't get any credit for being late. So I have to kind of think about what to do. And I don't want to take off, it's too hard to deal with taking off points for that. So yes, I recommend that you read it on time, but in reality, I think reading it at any point is good, right? Because you're learning the material. So as long as you read it by the end of the semester, however, it would help to read it before we get to the next chapter. That makes sense. So yes, did you have a question?
I answered it. Yeah.
Okay.
Yeah, I figured it.
Okay, great. And then also the other thing is if you feel like you have a week in the class where you're going to be gone, let's say you have a wedding or something to go to, I don't have the whole semester posted, but I do have a couple weeks ahead of time. So if you feel like, let's say you feel like this week is super easy and you're done, if you could get a head start on the following week, you always want to be ahead, because if something happens and let's say you get sick or something happens and you need to be off a week, then you don't get behind, because the worst thing to do in this class is to get behind, because things build on one another. So it's not like you could just say, oh, I'm just going to throw away chapter 2 and move on with chapter 3, because you won't understand chapter 3 if you don't understand chapter 2. And the chapters are really long and they take a lot to read. And so you don't want to get like a week or 2 behind, because that makes it really hard to catch up, if that makes sense. So working ahead whenever you have extra time, like if you have a week where you feel like you didn't have as much to do in your other classes, so you can get ahead, it's great because it gives you a little break if you need it later. Like, oh, I already read that chapter, I'm good, I'm ahead. So just some pointers I've learned in the past is getting behind is really hard to get caught up. So, and then don't hesitate to ask for help. That's the other thing. So if y'all are here, so if you want to stay after class, you can always stay after class. If you want to come on Mondays, you don't have to make an appointment or anything, just come and work. And you don't have to feel like if you come, you have to stay the whole class. I won't be offended. If you come and work for a little bit and you leave, or you come late, that's a work day. So you can come and leave whenever you want. Okay, I'll be here from 9 to 11:30. So whenever it's convenient for you, you can stop in and work. Or if you're having trouble online, just let me know and I'll get online and I'll help you online. There's also math. I know it's not as convenient because he's at Plano, but if you happen to be over at Plano, there's a tutor, Matt, and he's over there on Tuesdays and Thursdays. So if you happen to be over there on Tuesdays and Thursdays, he's also online on Fridays if you need help. So please don't feel like you're alone in this, like you have to struggle. Now, I want you to try to work through it on your own, because that's what's really going to help you. But I want you to, if you get stuck, ask for help. Like, I don't want you to feel like you're just alone out there and nobody will help. I can help you through it, or Matt can help you through it. Okay. So anybody have any questions? Are y'all okay online?
Where do you find Matt?
Matt's hours? He is.
Well, like, yeah, his hours, and like, where do you find him on campus?
Yeah, sure. So if you go to the modules and go to getting help, his hours are right here. And he's over at the Spring Creek campus in J119. He should be over there, and you shouldn't have to make an appointment on Tuesdays and Thursdays. However, things happen. So I really apologize if he's not there, like if he happens to be sick. The word doesn't always travel around to all the professors whenever he's not able to be there. You can always email him and make sure he'll be there ahead of time. If you're making a special trip over there, But if you happen to be over there, you can just stop in and see him. You can also make appointments with him on Friday for online help. So here's his hours. And then my office hours online, you can schedule an appointment by clicking on the link here. And what it does is it sends me a little notification. It puts it on my calendar. And then I just meet you in that Zoom room that I have right there at that time. I've been meeting a lot of students in there with having trouble with installation issues, like if you're trying to install Visual Studio or in my other class, NetBeans lately. But if you have a question, it's an individual office hour appointment, so other students won't be in there. So you can ask questions about your grade or your assignment. And if those hours don't work for you, most times during the day or at night, I can find some time to meet with you on Zoom. So just send me an email and say, are you free tonight to meet on Zoom? And I can set up an appointment for you. So just let me know, okay? But if those hours do work, please use this link because that helps me keep everything organized. Okay, so let me stop the